Welcome to Number Talks in the Elementary Classroom. In this module, we'll explore the transformative impact of Number Talks on mathematical thinking and learning for elementary students. We value your time and appreciate your active participation during this module. Here are a few suggested learning norms to make the most of your time. If possible, work in an environment with as few distractions as possible so you can engage and reflect. Take notes and jot down ideas and questions as needed. Lastly, use this time wisely to ensure your professional learning with university instructors is productive. Here is the agenda for today's module. First, we will start with learning objectives. Then we will move on to what are number talks, implementing number talks progression, and finally discourse and talk moves. By the end of this module, participants will be able to explain what number talks are and describe their benefits, implement number talk routines in the classroom, describe the progression of number sense and fluency goals from kindergarten to grade 5, and plan for teaching effective discourse using talk moves. Often, students see math as a set of rules and procedures to be replicated without truly understanding numerical relationships and concepts of number. Number Talks is a powerful instructional strategy that is grounded in developing students' mathematical reasoning skills and focuses on building conceptual understanding of numbers and computation. Here are the images of the Number Talks books on which this module is based. We highly recommend checking your school's professional library to see if they are available for use. In this module, we'll delve into the principles of Number Talks, discover effective strategies for implementation, and explore the numerous benefits they offer for both students and educators. Get ready to deep dive into the world of Number Talks and discover how they can revolutionize your mathematics instruction. We'll begin by exploring what number talks are and why instructors should incorporate them into their mathematics instruction. Number talks are short class discussions involving purposefully selected math problems that are designed to help students develop mental computation strategies. Students solve the problems in their head. Then the instructor facilitates a class discussion about how students solve the problems using mental math. Finally, the instructor may teach and encourage students to use different, more efficient mental math strategies. This process honors students' varied ways of getting to the correct answers while helping students move forward to more effective and efficient computation strategies. The major goal of Number Talks is building computational fluency, which means students have an efficient and accurate method for computing numbers. It is critical for students to make mathematical computations independently without relying on technology like a calculator. Mathematical fluency goes beyond mere memorization of facts. It is cultivated through understanding the underlying principles and relationships within numbers. Unlike memorization, which relies on rote learning, computational fluency empowers students to navigate numerical tasks with ease, flexibility, and assurance. With computational fluency, students can tackle mathematical challenges efficiently and effectively, demonstrating flexibility in their approaches and confidence in their problem-solving abilities. The benefits of incorporating number talks in your mathematics instruction are numerous and long-lasting. Benefits of number talks include, but are also not limited to, enhanced number sense. Number talks help students develop a deeper understanding of numerical relationships, patterns, and structures, leading to improved number sense and fluency. Also, improve problem-solving skills. By engaging in rich mathematical discussions and exploring multiple solution strategies, students develop critical thinking skills and become more adept problem solvers. Increased mathematical confidence. Through regular participation in number talks, students gain confidence in their mathematical abilities. They take risks in sharing their ideas and develop a positive attitude towards mathematics. Fostered mathematical community. Number talks create a sense of mathematical community within the classroom, where students can collaborate, support one another, and celebrate each other's mathematical successes. Students practice clarifying their own thinking. When students share and discuss computation strategies, they articulate that thought process, helping to solidify their understanding of mathematical concepts and approaches. And last but not least, consider and test other strategies. Engaging in discussions about computation strategies exposes students to alternative approaches. This encourages them to evaluate different methods, compare their effectiveness, and consider when to use each strategy. Before we get into the details of how to conduct a number talk with students, let's define two critical areas of mathematics we will be discussing throughout this module: number sense and fluency. Number sense refers to a person's intuitive understanding of numbers, their relationships, and how they are affected by operations, for example, addition, subtraction, and multiplication, etc. Number sense is the foundation for all higher level math skills. People with strong number sense can think and reason with numbers fluently, not just follow memorized procedures. It includes the ability to understand the meaning and value of numbers, recognize number patterns and relationships, make reasonable estimates, perform mental math, judge how reasonable an answer to a math problem is, and flexibility, use different strategies to solve numerical problems. Number fluency refers to a person's ability to understand, use, and manipulate numbers efficiently and accurately. Number fluency involves knowing how a number can be composed or created and decomposed or taken apart, and using that information to be flexible and efficient with solving problems. The image here is an example of decomposing the number 5, so listing different ways to make 5. We could also add 2 plus 2 plus 1 and 3 plus 1 plus 1 to the list. When someone has number fluency, they don't have to count by ones or draw a picture or write it out. They can mentally manipulate numbers or amounts confidently in their minds. The development of fluency with small numbers is paramount in laying a solid foundation for mathematical proficiency. Fluency with small numbers is a prerequisite for then building fluency with larger numbers and mastering other mathematical operations. Students who struggle with math often face challenges rooted in the lack of fluency in basic number sense. Fluency extends beyond mere memorization of facts. It also involves understanding how numbers can be composed and decomposed, enabling students to approach problems with flexibility and efficiency. Now that we have a basic idea of what number talks are and the purpose for using them, let's get into what number talks really looks like and how to successfully implement them into your math instruction. Let's break down the number talks process, then we will watch a video of this in action. First, have all students sit near each other in a central meeting location, such as the carpet or the rug, where you conduct whole group discussions. This helps encourage student discussion and keep everyone focused. Number 2, silently present the problem by writing it on the board or showing the page/card with the problem already written. You do not need to say it out loud. Number 3, allow students plenty of quiet wait time to mentally solve the problem. Number 4, students show a silent thumbs up by their chest when they found the answer in their mind. We ask students to keep their hands down and to only show a thumbs up by their chest so that other students can focus on their own mental math strategies. This helps give all students enough time to practice on their own without feeling rushed if they see all their peers raising their hands ready to answer. If students found the correct answer quickly, you can tell them to find a different way to get the answer and show how many strategies they have on their fingers. Number 5, ask students to share their answers, accepting all answers for the time being. You don't tell which is the correct answer yet. Then have a few students share how they got the correct answer and explain their thinking, writing it on the board so all students can visualize it. Eliminate and discuss any incorrect answers. And number 6, encourage students to use more efficient mental math strategies by either highlighting a strategy other students are using or by explicitly teaching and modeling using a new strategy to solve the problem. In the following video, a grade 2 through 3 instructor will conduct a number talks with her class. As you watch, try to answer the following questions. What was the initial problem presented to the class? How did the instructor handle incorrect responses? How did the instructor record student thinking? And how did the instructor extend the instruction to highlight and encourage a new strategy?
Are you guys ready for some number talks?
Yeah.
All right, here we go. Here's your first problem.
$48.
You see some agrees. Anybody come up with a different answer than 48?
I came up with 49.
49, okay. Any other answers other than 48 and 49? Okay, we have two answers now, so what we're going to do is we're going to justify our thinking, okay? So that we can choose one of these answers or come up with a different answer. Okay, so I'm going to go back to you. I want you to talk me through your thinking.
39, so it would be 40, and then you have 8 left.
So you partition this number with 1 and 8, and you move the 1 over here. So you're telling me that 39 and 1 more makes what?
8. 40.
Good. Okay, keep going with your thinking.
And then you have 8 left, right?
And 40 plus 8 is?
48.
Good job. Very good thinking. So you made a friendly number to solve that problem. That's great. Anybody use a different strategy to solve 39 plus 9?
39 plus 10 equals 49.
Ooh.
But we weren't doing 10, so I did 39 plus 10, and then I subtracted 1 and got 48.
Good job, Caitlin. Did you guys see what she did? She said that she pictured this 9 as a 10 because it's very close, right? And adding 10 is always something that's very easy for us, right? And she said that 39 plus 10 more makes 48. And then she went back, and since it wasn't 10, it was 9. She took 1 away and got 48. So we know now that 39 plus 9 is 48. Do you all agree?
Yeah.
Use that to help you solve this next problem. Here we go.
57.
Okay. I see some agrees. Did anybody come up with a different answer? Okay, all right. Talk me through your thinking then.
So I added 1 to the 39 to make it 40.
From 18.
Yes, and I added the 40 to, I added the 10 to the 30 to make it 30, make it 40, and I added that 1 to make that 50, and so I had 7 left, so it's 57.
Okay, because if you have 1, what's your other part of 18? 1 and what makes 18? Have 11.
17.
Yeah. So now I know that I have this much more to add. So 40, what'd you
And
do?
then I added that 10 to the 30.
The 10 from the 17?
Yeah, to get to the 40. And so I got 50 from there. And then I added the 7 so that I could get 57.
Great job. Excellent thinking. Very good. Who did something different?
39.
Mm-hmm.
Then I did 39 plus 10.
Okay, the 10 from the 18.
I did 39 plus 10.
Uh-huh.
But that gave me 49 because I had to use one of them because it was 9, not it was 39, not 40. So I had to use one to make the 40, and then I got the 8.
Yep.
I added one of them to make the 40 to a 50, and then I had 7 left.
Okay, so you even broke that number into 1 and 7, and you added 1 to make 50, and then what did you have left?
7.
Wow. That's amazing. You are really thinking flexibly about numbers. That's a great job.
I'm learning about this. So, like, we break up both numbers into their numbered sentences.
Explain that to me. Talk me through that.
So it's like 30 plus 9 for the 39, and then 10 plus 8 for 18. And then all we do is add the 10s together.
Okay.
And the
Which would be how much?
40. And then we add the ones together. 17.
Good. And then what do you know about 40 plus 17?
That I could just add the next 10, and then I have 7 more, so then I know it was 57.
Good job. Very good. Give yourselves a pat on the back. That is some awesome thinking. Your brain.
In this video, we observed a number talks activity led by an instructor in the classroom. The instructor first presents the problem 39 plus 9 to the students, initiating a discussion on different strategies for solving it. Number 1, the student responses. So students share their solutions, with some suggesting the answer is 48 and others proposing 49. The instructor encourages students to justify their thinking, prompting them to explain their strategies step by step. For the explanation of strategies, one student explains their strategy of partitioning the number 9 into 1 and 8, making it easier to add to 39. Another student visualizes the number 9 as 10, making it simpler to add to 39 and then adjusting for the extra 1. Students demonstrate diverse strategies, such as breaking down numbers, using friendly numbers, and visualizing the problem. For validation and synthesis, the instructor validates the correct answer of 48 and summarizes the various strategies used by students. Students are then encouraged to use the agreed upon strategy to solve related problems, such as 39 plus 18. For further exploration, students continue to share their approaches for solving related problems, such as splitting 18 into 10 and 8, or using number sentences to break down the problem. In terms of frequency and duration, conduct number talks daily for around 10 to 15 minutes. It will take a little longer in the beginning as students learn your routines, but it will get much faster. And then more you and your class practice, the students get comfortable with the routines. Consistent, brief sessions are more effective than occasional longer ones. And number talks are not your whole math lesson. They should be no more than 15 minutes and shouldn't take up your whole math block. Treat them like a warm-up or incorporate them into another daily class routine like morning meeting. So when selecting problems, choose numbers and problems based on insights from previous number talks and consider where your students are with their number sense. If most of your students are unable to decompose numbers to 10, then you should probably start with problems with a sum less than 10. Align problem selection with the focus of ongoing classroom instruction. For example, if you're working on an addition and subtraction unit and students are working on 5 plus problems, use the 5 plus problems like 5 plus 3, 5 plus 4. Use those in your number talks. Then extend that strategy. So for example, to 6 plus 3 and 6 plus 4. Finally, provide ample opportunities for students to practice similar types of problems. Encourage students to try more efficient strategies by highlighting or explicitly teaching new strategies. This reinforces strategies and builds fluency. Try the following to hold students accountable when implementing number talks. Encourage students to use finger signals to communicate the most efficient strategy during problem-solving activities. Maintain records of the problems presented and the strategies students employ to solve them for future reference and assessment. Organize small group number talks to facilitate deeper mathematical discussions and exploration of various solution strategies. Develop and display class strategy charts to visually represent the different approaches students use to tackle mathematical problems. Conclude each session with an exit problem that challenges students to apply the strategies discussed during the number talk. When you first start implementing number talks, begin by teaching, modeling, and reinforcing the process, routines, and expectations for students. Start with simpler math problems at the beginning so you and your students can focus on the routines and then build their confidence sharing their math thinking in front of the class. Define and teach specific hand signals that students can use to communicate during number talks. Hand signals include a closed fist by their chest for I'm still thinking, a thumbs up by their chest for I have an answer / I'm ready, showing multiple fingers to indicate how many ways to find the correct answer or numbers of strategies that you have, showing fingers to represent numbers, thumbs up for agreement, and or thumbs down for disagreement, and etc. You may choose to display these visual reminders of the hand signals like a poster or modeling the signals yourself to reinforce their usage and help students remember them during discussions. This can include posters or anchor charts illustrating the signals and their meanings. As the instructor, your role includes facilitating mathematical discourse. Your role during number talks is to create a safe and supportive learning environment where students feel encouraged to share their mathematical thinking openly. You guide discussions, pose probing questions, and scaffold students' understanding by providing strategic prompts and feedback. You also model mathematical thinking. By actively participating in number talks alongside your students, you intentionally model effective problem-solving strategies. You're demonstrating those mathematical reasoning processes, and it showcases the value of perseverance and flexible thinking. Active engagement encourages your students to emulate similar behaviors and approaches in their own mathematical explorations. Finally, you prompt student agency. So through number talks, instructors empower students to take ownership of their learning, and they become active participants in the mathematical sense-making process. By valuing all contributions, fostering a growth mindset, and encouraging peer collaboration, you cultivate a classroom culture where every student's voice is heard and respected. When students are sharing their thinking, the instructor should record what they say and ask clarifying questions to ensure that the whole class understands the strategy. You can ask a student, how do you know? Tell me more. How did you figure it out? Why did you do it this way? What did you do next? Did someone solve it a different way? Who else used this strategy to solve the problem? And which strategy seems to be the easiest or fastest? By asking students to explain their thinking, you are building and/or reinforcing computational skills and fluency. Part of the number talks process is to create a safe space for students to make and learn from their own mistakes. Why do we accept wrong answers when that could lead to misconceptions? Well, consider the following growth opportunities. Number one, encourage students to articulate the reasoning behind their answers, fostering deep understanding and critical thinking skills. Number two, cultivate an environment where students feel empowered to contribute to the evaluation of answers, promoting collaborative learning and a sense of ownership over mathematical discourse. Number three, shift the role of the instructor from being the sole authority to that of the facilitator who guides discussions and encourages student-led exploration of mathematical concepts. Number four, view wrong answers as valuable opportunities to uncover and address misconceptions, allowing students to refine their understanding through self-reflection and peer feedback. Number five, encourage students to analyze their thought processes behind the incorrect answers, fostering metacognitive skills and promoting a growth mindset towards learning from mistakes. And number six, emphasize the role of mistakes as integral to the learning process, as they provide opportunities for students to question, analyze, and refine their thinking, which ultimately strengthens their conceptual understanding of mathematics. By embracing wrong answers as valuable learning experiences, instructors can create a supportive learning environment where students feel empowered to engage deeply with mathematical concepts and develop resilience in problem solving. When you are sharing and discussing student strategies, it can be helpful for students if you name or label the strategies that students use. Then these strategies can be practiced and reinforced during future number talks. These mental math strategies may include doubles or near doubles, recognizing and leveraging patterns in doubling or nearly doubling numbers. Number 2, breaking numbers apart. So decomposing numbers into smaller, more manageable parts for computation, such as the example of solving 5 plus 6 by splitting 6 into 5 and 1. Adding up in chunks, summing numbers by grouping them into convenient chunks for mental calculation. Making landmark or friendly numbers can include selecting or adjusting numbers to more easily perform calculations, often using round or easily divisible numbers. Friendly numbers are usually decade numbers like 20, 30, or quarter numbers 25, 50, 75. For example, solving 5 plus 6 by splitting 6 into 5 plus 1, then adding 5 plus 5 to get 10, which is a friendly number. It's easier to add 10 plus 1 than 5 plus 6. Compensation. Adjusting one or more numbers to simplify the problem or compensate for complexity. For example, to add 39 plus 8, I can add 40 plus 8 to get 48 and then subtract the 1 added to the 39, which makes my answer 47. Adjusting one number to create an easier problem, which means manipulating one of the numbers in a problem to make it simpler to solve. Naming these strategies allows for consistency and reinforces multiple approaches to solving problems. Some more mental math strategies to highlight or encourage include, but are not limited to, number 1, making tens, restructuring numbers to create combinations that add up to multiples of 10 for easier mental arithmetic. Number 2, doubling and halving, using the strategy of doubling or halving numbers to simplify calculations. Number 3, breaking factors into smaller factors, decomposing factors into smaller, more manageable components to facilitate multiplication or division. Number 4, thinking about money, applying concepts related to currency and monetary transactions to mathematical problem solving. Number 5, traditional algorithm, employing standard step-by-step procedures for arithmetic operations. And number 6, counting on, incrementing from a given number to reach the desired sum or result. By recognizing and naming these strategies, educators can help students develop metacognitive awareness and build a toolkit of effective problem-solving approaches. This is an example of the work students did during a number talk session solving 9 multiplied by 16. And how they shared the strategies they used to solve the previous problem. The instructor labeled the strategies using friendly numbers, using partial products, breaking a factor into smaller factors, and using doubling and halving. An instructor can assess number talks using a variety of methods. Utilize Post-it notes, exit tickets, or flip chart paper to gather feedback and responses from students after number talk sessions. Consider using pictorial evidence such as drawings or diagrams created by students to assess their understanding and application of mental strategies. Implement mental strategy assessments to evaluate students' proficiency in employing various mathematical strategies during number talks. These assessment methods provide valuable insights into students' mathematical thinking and help inform instructional decisions to support their learning and growth. How do I design purposeful number talks in the K through 2nd grade classroom? Start with accessibility. Begin number talks with simpler problems below students' current grade level to establish foundational understanding and build confidence. Take it slow and go fast. Starting small allows students to focus on understanding mathematical concepts without feeling overwhelmed and provides a solid foundation for gradually building students' mathematical proficiency. Gradually increase the complexity of number talks as students become more proficient, providing a scaffolded approach to learning. Use visuals and models. Use dot images, 10 frames, and Rec and Rics to support students who need extra help visualizing amounts. This is particularly helpful for younger students in grade K through second grade, but can be used and modified for older students, especially when discussing place value, fractions, and decimals, or etc. Incorporate visuals and models into intervention strategies for students struggling with mathematical concepts. Introduce students to a variety of models to deepen their number sense. Encourage the use of physical and virtual models to enhance student engagement and facilitate hands-on learning experiences. Small group differentiation. So depending on your students' needs, you may choose to utilize small group number talks during intervention sessions or guided math time to provide targeted support and personalized instruction. Take advantage of small group settings to more carefully observe students' problem-solving strategies closely and address individual needs effectively. Now that we have learned how to implement number talks, let's take a minute to reflect on the content. How will number talks support the development of number sense in my students? What challenges do I anticipate and how might I address them? And what is one action I can take this week to begin or improve number talks in my classroom? Pause the video to jot down your thoughts. Now that we understand what number talks should look like in the basic routines, let's discuss the progression of content used for number talks. Goals for students in grades K through second include number sense. So number talks aim to develop a deep understanding of numbers and their relationships, laying the foundation for mathematical proficiency. Fluency with small numbers. So through number talks, students build fluency with basic arithmetic facts such as addition and subtraction within 10, which is essential for mathematical success. Substitutizing number talks helps students recognize and instantly identify small quantities without counting, enhancing their ability to visualize numbers and understand numerical patterns. Making tens. Students learn strategies to efficiently combine smaller numbers to make 10, facilitating mental calculations and problem solving with larger numbers. What area you work on and the level of difficulty you choose will be determined by where your students are in their mental math abilities. The following slides include examples of suggested grade level work, but always keep your students' needs in mind. In grades K through second, number talks can often include physical representations of numbers using different materials such as dot cards, 10 frames, and Rec and Rics. These tools help students visually see the amount that the numeral represents, which leads to a stronger ability to mentally manipulate different amounts. When using dot cards for number talks, you would show students the image and ask, how many dots are there? And encourage students to figure it out without counting all the dots by ones. Once students have their answers, you would ask students to share. How did you know how many dots were there? How did you see the dots? And use that to begin a discussion. For the dot card examples shown here, students will likely say they saw 5 and 3 to make 8. Some students may say they saw 5 and then counted up 6, 7, 8, or that they saw 4 and 1 making 5, plus 3 more to make 8. Similarly, with the tens frames, you would show the image of the tens frames and ask, how many dots are there? And once students have had time to think and ask, how do you know, and how did you figure it out without counting all the dots, to begin discussion. If your students are working on ways to make 10 or 20, you might extend their thinking by asking, how many more dots would I need to make 20? In kindergarten, number talks often involve using visuals like tens frames or dot cards, usually starting with numbers up to 5, then moving to numbers up to 10. We ask questions like, how many dots do you see, to encourage students to count and recognize numbers. For example, we might ask, How did you see that number? To prompt students to explain their thinking. Moving to grade 1, we start with simple addition and subtraction problems within 10, then move up to numbers within 20. Students use strategies like counting on or breaking numbers apart to solve problems. For instance, they might solve 6 plus 2 by counting on from 6, saying 7, 8. Decomposing a number means taking a whole number and breaking it into 2 smaller parts. To decompose the number 6, you can break it into smaller parts of 3 and 3 or 4 and 2. In grade 2, we progress to larger numbers and more complex operations, such as 2-digit addition and subtraction. Students continue to use strategies like making tens or using doubles to solve the problems. Goals for grades 3 through 5 Number Talks include number sense. So Number Talks aim to deepen students' understanding of numbers and their relationships, fostering a strong foundation for more complex mathematical concepts. Place value. Through Number Talks, students develop a deeper understanding of the value of digits and multi-digit numbers and how they relate to each other. Fluency. Number Talks help students become fluent in arithmetic operations with larger numbers, including addition, subtraction, multiplication, and division. Properties. Students explore mathematical properties and relationships such as commutative, associative, and distributive properties through discussions and problem-solving activities. Connecting mathematical ideas. Number Talks encourage students to make connections between different mathematical concepts, such as fractions, decimals, and percentages, promoting a deeper understanding of mathematics as a coherent system. Fractions, decimals, and percentages. Moving into higher math content, students will practice fluency, thinking about equivalencies using fractions, decimals, and percentages. Again, what area you work on and the level of difficulty you choose will be determined by where your students are in their mental math abilities. You may have students in grade 3 through 5 who still need to work on mental math skills listed in grades kindergarten through 2nd. The following slides include examples of suggested grade level work, but always keep your students' needs in mind. For 3rd grade, we include multiplication and division facts up to 100. Students use mental math strategies like skip counting, grouping, or using arrays. For instance, they might solve 4 times 5 by skip counting by 4s, 4, 8, 12, 16, 20. In 4th grade, we extend to include more challenging multiplication and division problems. Students are encouraged to explain their thinking and justify their answers. For example, they might solve 15 divided by 3 by using an array model and explaining how they divided the total into equal groups. Finally, in 5th grade, we introduce fractions and decimals into Number Talks. Students focus on concepts like equivalent fractions and decimal place value. See the examples shown here. Students would need to use understanding of equivalent fractions and decimals to determine that the image in the first box is showing 2/3 on a number line, while all the other images represent 1/3. Therefore, the first box does not belong. Now that you better understand the progression of Number Talks, let's reflect on how this impacts instructional practice. Consider these 2 questions. How can I build on what students have learned in earlier grades while preparing them for future concepts? And what is one adjustment I can make to better align my Number Talks with students' developmental progression? Pause the video and consider your responses. We have learned about Number Talks at each grade level, so now let's delve into the critical components of effective math discourse, focusing on talk moves. We'll explore how discourse in the math classroom can enhance student learning and understanding, and we'll specifically highlight the importance of employing effective talk moves to facilitate productive discussions. Talk moves are strategies used by instructors to facilitate meaningful mathematical discussions in the classroom. These moves encourage students to engage in mathematical discourse, sharing their reasoning, and deepen their understanding of concepts. Talk moves empower students to articulate their thought processes, collaborate with peers, and construct viable arguments. By employing talk moves, instructors create an inclusive learning environment where all students will have the opportunity to participate and contribute to the mathematical conversation. These moves help guide discussions, promote critical thinking, and support the development of mathematical communication skills. Talk moves are essential tools for fostering a collaborative classroom culture and promoting mathematical proficiency among students. So how can we conduct these moves? Talk moves and number talks include: number 1, revoicing. The instructor repeats or rephrases a student's response to ensure understanding and clarity. This allows the instructor to validate the student's contribution and encourages further elaboration. Repeating. The instructor restates a student's response, emphasizing key points or strategies. This reinforces important concepts and encourages active listening among students. Restating a student's response reinforces understanding and confirms accuracy. Number 3, reasoning. The instructor prompts students to explain their thinking and reasoning behind their answers. This encourages students to articulate their thought processes and promotes deeper understanding. It also engages students in explaining the thought process behind their strategies and choices. Number 4, adding on. The instructor invites other students to build upon or extend a classmate's response. This fosters collaboration and encourages students to consider multiple perspectives. Additionally, it encourages students to build on or extend their peers' ideas, fostering collaborative learning. Number 5, wait time. The instructor allows sufficient time for students to process questions and formulate responses. This creates a supportive environment where students feel comfortable expressing their ideas without rushing. Instructors allow pauses after asking questions or pose problems to give students time to think. And number 6, turn and talk. The instructor prompts students to discuss their ideas with a partner before sharing with the whole class. This encourages total active participation and provides opportunities for peer collaboration and learning. Instructors facilitate peer discussions and collaboration by having students share their ideas with a partner. Imagine the following scenario. During a number talk session, the instructor poses a problem and asks students to solve it mentally. After allowing time for individual thinking, the instructor initiates the following discussion using talk moves. Instructor: which strategy did you use to solve the problem? Student: I used compensation to make the numbers easier to work with. Instructor: so you adjusted the numbers to simplify the calculation? Student: yes, I added 10 to one number to make it a multiple of 10, then subtracted 10 from the other number. Instructor: you added 10 to one number and subtracted 10 from the other to make the problem easier to solve. Which talk move did the instructor use? The instructor used revoicing and repeating. For revoicing, they said, so you adjusted the numbers to simplify the calculation. Notice how the instructor restates the student's response to confirm understanding. Then the instructor paraphrases the student's explanation to ensure clarity and validation of the student's contribution. Number 2, repeating. You added 10 to one number and subtracted 10 from the other to make the problem easier to solve. Pay attention to how the instructor repeats key points made by the student to reinforce understanding. The instructor repeats the student's strategy to emphasize its significance and provide clarity for the class. Let's extend this example with part 2. Talk moves example part 2. Instructor: can you explain why you chose to use compensation in this situation? Student, I know that adding and subtracting multiples of 10 is easier for me, so I adjusted the numbers to make the problem more manageable. Instructor, does anyone else have a different strategy or want to add to what was shared? Student, I used a different strategy. I broke the numbers apart into tens and ones and added them separately. Instructor, pauses to allow other students to contribute. Instructor, now, discuss with your partner which strategy you found most helpful and why. Which talk moves did the instructor employ? The instructor employed reasoning, adding on, wait time, and turn and talk. For reasoning, can you explain why you chose to use compensation in this situation? Observe how the instructor prompts the student to explain their reasoning behind the chosen strategy. The instructor encourages the student to articulate the rationale behind their approach, fostering deeper understanding. Adding on, does anyone else have a different strategy or want to add to what was shared? Notice how the instructor invites other students to share alternative strategies or add to the discussion. The instructor promotes collaborative learning by encouraging multiple perspectives and strategies from students. For wait time, the instructor pauses to allow the other students to contribute. Pay attention to how the instructor allows for pauses to give students time to think and respond. The instructor incorporates wait time to ensure all students have the opportunity to contribute and reflect on the discussion. And number 4, the turn and talk. Now, discuss with your partner which strategy you found most helpful and why. Notice how the instructor facilitates peer discussion by having students share their thoughts with a partner. The instructor promotes interactive learning through peer dialogue, encouraging students to articulate their ideas and engage in meaningful discourse. To foster deeper student discourse, start with the whole group and small group discussions before introducing more complex formats. For whole class discussion, the teacher presents a math problem to the class and facilitates a discussion where students share strategies and solutions, learning from each other. For a small group discussion, students work in small groups to explore the problem collaboratively, allowing for focused dialogue and peer feedback. For pair share activities, partners discuss their strategies, helping each other refine their thinking before sharing with the class. For think pair share, students first think independently, then discuss with a partner, and finally share with the whole class to ensure everyone engages. For Socratic questioning, the teacher uses open-ended questions to prompt reasoning and justification, deepening students' understanding. And for role-playing, students take on roles. For example, mathematician or a skeptic, to explore different perspectives and engage in mathematical argumentation. To summarize what we've covered in this module, here is a summary of the learning. Number 1, Number Talks are short, daily, student-centered math discussions aimed at developing mental math strategies, number sense, and computational fluency. Number 2, Instructors present purposefully selected problems, facilitate discussion using hand signals and talk moves, and guide students to share, justify, and reflect on mental math strategies. Number 3, Number Talks evolves from composing and decomposing numbers and simple operations in grades kindergarten through 2nd to more complex strategies for addition and subtraction, as well as fractions, decimals, and multiplication and division in grades 3 through 5. The instructor acts as a facilitator, encouraging mathematical discourse, modeling and recording student thinking, and creating a safe space where students' mistakes are learning opportunities. There is an emphasis placed on student reasoning and participation using techniques such as revoicing, repeating, wait time, and turn-in talks to foster class collaboration and critical thinking. Thank you for your time and attention. We hope you learned some valuable and practical information to begin implementing Number Talks in your classroom. Please take advantage of the resources on the next few slides and within the Google Classroom to enhance your implementation of Number Talks in your classroom.